Hey guys, Mr. Gonzalez here doing a little tutoring on naming ionic compounds. So let's do it. Let's talk quick about what an ion is. If you remember on the periodic table, when we did our electron configuration stuff, these guys right here in the first column, they all have one valence electron. And we talked about how valence electrons are the outermost electrons. So like lithium, it's just got one more on the outside, and so does sodium, potassium, rubidium, and so on. And these guys over here have two. These guys are two. And these guys over here have three on the outside. 1, 2, 3. We sort of ignore the middle for now because the middle has their valence varies. They can vary. So 1, 2, 3. Let's start with those. So lithium, we'll use, let me erase this here. We'll use 3 examples. From the first column, we'll use lithium. Second column, we'll use magnesium. Third column, we'll use aluminum. So these 3 right here. So the first thing you need to know for an ion is any sort of, it's one of these that has a charge on it. So it's lithium, for example, loses an electron because it has one. If it loses that one electron, it's happier. It'd be acting more like helium, like we said in class. So since it loses one electron, it's going to be positive. Now that's a little confusing for some people, that why is there a positive if it's losing an electron? Well, just think about how, for example, that the inside of a lithium atom is positive, and it's surrounded by that one, it's got that one electron over here. If it loses that one negative thing, the nucleus, since the nucleus is very positive, it's going to be more positive. So that's why it gets a plus. Magnesium gets a 2+. It has a charge of 2 because, well, it's in the second group. And these guys in the second group, they want to lose 2 electrons so they could be more like the noble gases. So magnesium, go over here, let's do magnesium. Magnesium's a 2+ because it's trying to lose the 2 electrons. And aluminum is the only one you need to know for your quiz that's a 3. Okay, so that one's a 3. That has 3 over here. There's 3, there's aluminum. 3 electrons from being like neon. Okay? Now, we're going to ignore these guys right here. These are the +4, -4. They don't really become ions that easily, so we're going to sort of not talk about them at all. This is sort of our border here. So this is our +1 dudes, our +2 dudes, and our +3. Now for the quiz, you can totally use your periodic table, so you will know the charges of these. Okay? The next thing is, going this way, well, fluorine, chlorine, bromine, iodine, those guys are 1 away from being away. So they want 1 electron. And if you get 1 electron, you're going to be -1. These guys want 2 electrons, oxygen and sulfur. Those are the ones that you need to know. And these guys, well, they need 3 more to be like noble gas, which is hard, by the way. So these are the ions that form from, those are the charges that these elements have. Okay, so that's the first thing you need to know is, how do I find their charge on the periodic table for the quiz? So if I give you bromine, you just look it up. You're like, hey, bromine, what's up, bro? You know what I mean? So let's do this. Bing. We did this in class, and that kind of confused some people, so let's go over that a little bit. Monoatomic is, it just means like it's in the periodic table if it's monoatomic. So monoatomic cations, monoatomic anions. Monoatomic cations are the first 3. These are your monoatomic cations. These 2 and aluminum. They're the ones that are cations are positive. Okay? Anions are negative. And so these are your anions over here. They're the ones you're going to use. Your monoatomic anions. Monoatomic, monoatomic. So here we go. Monoatomic cations, I'll just give you a couple. Potassium, we got calcium, we got magnesium, we got aluminum. Okay, that's getting annoying. Hold on, this is a 3+. And then over here, your monoatomic ion, chlorine, oxygen, nitrogen. Now the cool thing, when you name these in a compound, they have the same name. Like for example, this is going to be magnesium. It's the magnesium ion. okay? But these guys right here are the ides, we said in our notes, remember? So this is nitride, oxide, chloride, sulfide, phosphide, bromide, okay? Cool. So those are your monoatomic dudes. Polyatomic is your CO3, your NO3, your SO4, what else? NH, OH. These guys are, oh, there was chlorate, was the other one. These are your eights for the most part, except for these guys, of course. This guy up here is carbonate, nitrate, sulfate, chlorate. Now, these numbers have been confusing people all week. Ignore them. It just means this whole compound here, which is hooked together with covalent bonds, by the way, it's hooked together, it has a charge. Like this chlorate, this carbonate right here has a 2 negative charge. So that just means this whole guy has a charge. It's an ion if it has a charge. So these are polyatomic. This is nitrate. Nitrate has a negative charge. Sulfate has a 2- charge. Now I'm going to give you this for the quiz. I'll give you a little chart that shows their charges so you know what they are. I will not give you these two. These two you have to look up, the first two in the periodic table. Ammonium is the only polyatomic cation. You see, it's a cation. All the other dudes are anions. And this guy's hydroxide. All right, so let's start naming them. Yeah? Yeah. Naming. Mono y mono. How do you say this? Salt. No. What you do is you say the first one and then say the second one. So remember, cations is the same thing. Cation is, I was about to say nah. Cation is sodium. This is sodium, the way you write it. Sodium. And then this is chlorine, but you don't say it chlorine since it's an anion. It's an ide, remember? So this is sodium chloride. Cool, cool. So let's do more mono y mono. Actually, let me erase this so we have more room. Mono a mono. Here's some more monos. Oh, K2O. Is that right? Absolutely. K2O. Potassium oxide. Magnesium oxide. How about sodium nitrate? Man. That's like a bread in India. It's like naan. It's delicious. All right, sodium nitride. Now, here's what's crazy. We're not done with this one because we have to write charges. So the charge for sodium, it's in the first column, so it's plus. And this guy right here is 3 minus. So we do the crisscross rule. Remember, this guy goes here. This would be a 1 because this is really like a 1. We don't, apparently chemistry doesn't like 1s. So this right here is a 1. This would go here, but we don't write anything because, again, chemistry doesn't like 1s. And this one right here would be a 3. So this be sodium 3 nitride with a little 3. But how do you say it? You don't say, oh, this is so sloppy, I'm sorry. Sodium nitride, which doesn't seem like it exists. But how do you say this? You don't say sodium 3. All you say is sodium nitride. That's what you would write on the quiz. This is sodium nitride. Now, wait a minute. How come this one didn't get any numbers? Let me check this one here. This is a 2 minus, and this guy's a plus. Crisscross 1, crisscross 2. Awesome. K2O is correct. Potassium oxide. Potassium oxide. And this guy right here, remember, the reason there's no numbers here, this has a charge of 2 minus, and this has a charge of 2 plus. When you crisscross, they're both 2, 2, but we cannot write Mg2O2 because that makes no sense. You'd basically be saying, hey, for every 2 magnesiums, I need 2 oxygen. No, for every 1, I need 1. So you simplify the numbers. So you can use this, by the way, to figure out the charges of stuff. I'll show you that in a little while. Mono with poly. Mono with poly is like saying potassium carbonate. And now the charge for carbonate is 2 minus. So pretend there's a 2 minus here. I'm going to crisscross it so it's K2CO3. Notice no parentheses. Let's do one where you need parentheses because you guys, magnesium nitrate. These are your 8s, remember? Your polyatomic dudes, 8s. Magnesium nitrate. This has a charge of 2. This has a charge of -1. This has 2. So I'm going to crisscross and put a 2 there. But we don't want to make it look like 32. So there you go. You put a 2 on the outside. So that's magnesium nitrate. And we'll do one more. Lithium hydroxide. Liar. You're a liar. This is plus and this guy's minus, so they get no numbers, anything. That one's totally fine. 2 polys. Here's the trick. The only positive we have is ammonium. So this is ammonium. And we can hook up ammonium with anything we want. So let's get rid of the charge. Remember, once they hook up, they're neutral, so they get no charges. You cannot write charges. So this is NH, and we're hooking it up with, let's hook it up with someone who's exactly the same opposite charge. So NO3. Ammonium nitrate. Cool, let's write that, ammonium nitrate. Let's hook it up with ones where the charges don't totally perfectly match. So again, we got to use ammonium because it's the only one that we have that's a plus. And let's hook it up with phosphate. Now, if you think I have all these charges memorized, you crazy. So I look it up, and you're going to look it up. It's phosphate. It's 3. It's 1. Cool. Do I need parentheses? No. You only need parentheses if there was something written after after phosphate. Okay? So let's do one where that happens. Oh, we can't because ammonium, we can't. They won't get parentheses because ammonium's only a 1, so that won't happen. Okay? Okay. So let's end with that. And the last thing we're going to give you is dudes with multiple charges. So there's some metals that lose like different amounts of electrons. Like we made a list. We said it was iron. We said it was copper, gold, tin, and there was somebody else. Who was it? I can't remember. Lead. All right. So these get a little confusing too, but not a big problem. Just remember, like Fe could be Fe1. By the way, they're all positive because they all lose electrons. You can have iron 2 or iron 3. Okay, so that's why these guys can have multiple charges. So it's a little confusing. I'll write some down and we can talk about it. Let's just use iron because that one's fun. That means ugly in Spanish. We said that today in class. That was funny. Okay, FeNO3. Okay, if you get these guys like this, these 3, these are different irons. Maybe. Yes, all 3 of these are different irons. They could be iron 1, iron 2, or iron 3. Well, how are you going to know what they are? So the way you'll know what they are is by the other thing, the anion. So I know that oxygen has a charge of 2 minus. That means if I do the crisscross, this would be Fe2. But there's nothing written there. There should be a 2 there. Why isn't there a 2 there? Well, it means that there was probably a 2 here. Because we wrote Fe2O2. You see what I'm saying? I crisscrossed. But we can't write this. We can't say for every 2 irons, there's 2 oxygen. 1 to 1. So that's why this says FeO. That means the way we write this dude is we're going to write it like this. We're going to say it's iron 1 oxide with a Roman numeral 1 here. Okay? Never, ever, ever use these numbers to name this iron. Like this is not iron 2 oxide. It's not. So what is it? Reverse crisscross. This 3 right here came from up here. That means this was a 3 plus, and this 2, of course, comes from the oxygen. Reverse crisscross. So that means that this iron right here, this is iron 3 oxide. What's the charge of this? Well, I'll give you a little hint. The charge of NO3 is just negative. NO3 is just negative. So think about it. Is this iron 1? Is this iron 2? Is this iron 3? It says FeNO3. Well, this has to be iron 1. Oh, sorry, did I mess this up? Yeah, I messed this one up here. Man. This is iron 2 oxide. Iron 2 oxide. Stupid. It's called iron 2 oxide because it has a charge of 2. We don't call it iron 1 because we simplified the numbers. I'm so sorry. So this is iron 2 oxide. I'm a little dizzy today. Now this guy is iron 1 oxide. Ooh, sorry, it's not an oxide. You're so crazy. This is a nitrate because it's 8. Okay? All right, so that's how we do the crazy charges. I'll put a couple more because I know you're like, what? What? I have no idea, Mr. G. All right, so let's do this one. Let's see what's hold on. Let me do. I'll do let's do this one. Oh boy. Awesome. Like awesome. And then we'll do. All right, we'll do those two, and then we'll end with that. Awesome. Let's do the awesome one. This is gold. That's sulfur. Gold sulfur. Gold plus sulfur. Sulfate. Sulfide. Remember, it's an ide because it's just an S. So this is gold sulfide, but gold what? Well, what you do is you look up this in the periodic table, and it turns out it's right under oxygen, which means that it has a charge of 2 minus, because it wants 2 more electrons to be like its hero, the noble gas. That means there should have been gold 2 there, but there's nothing, which means this must be 2 plus. So the way we write this is gold 2 sulfide. And this guy right here, well, reverse crisscross, this one's easy, man. This one's gold 3 oxide. Guai. Because this 3 is this 3 up here, and this 2 is this 2. Got it? Got it. All right, awesome. Good luck, guys. Good luck. May the force be with you.